How many people bought the ticket because they like the price? Can you answer me? How many people bought the ticket because they like the price? 75. So we have 75 people who bought the ticket because they like the price. Okay. So now the total number of people who bought the tickets are how many?
100.
100. So if we want to get the probability of those who bought the ticket because they like the price, we are going to take 75 divided by what? 100. So the probability that
Divided by 100.
it was bought by someone who liked the price is 75 divided by what? 100. And that will give you
100.
that will give you the probability.
75%.
So 75% divided by 100 will give us 8. So the probability that the prize winning ticket was bought by someone who liked the price is 75 divided by what? 100.
100.
Yes, so you will get 0.75, isn't it? Then let's go to the B. The B says, what is the probability that the prize was won by someone who did not support the charity? How do you get this one? What is the probability that the prize was won by someone who did not support the charity? So to find this, what that means is that we are going to find the probability that you supported the charity. So the probability that you bought the ticket because you supported the charity is 60 over 100, isn't it? So we get 60 over 100. So the probability that you bought the ticket because you supported the charity is 60 over 100.
Yes.
But we want to find the probability that the prize was won by someone who did not support the charity. So what that means is that we are going to have 1 minus the probability that you bought the prize because you supported the charity. So that is going to be 1 minus 60 over what? 100. 1 minus 60 over 100. And that will be the probability that the prize was won by someone who did not support the charity. And then the final one, what is the probability that the prize was won by someone who both supported charity and liked the prize? So what are they looking for in C? They are looking for the intersection. So because they are saying that what is the probability that the prize was won by someone who supported the charity and also liked the prize? So we are looking for the intersection here. So this is how we solve this. So if you come to this place, we will say that let A and B be the events like the prize and supported the charity respectively. So the event that you supported the charity is A, and the event that you like the event that you like the prize is A, and the event that you supported
can't hear you.
is B. Now the total, so what we want to find, so to find the probability of A, that is probability of that the winning ticket was bought by someone who liked the price. So we are looking for probability of the one who liked the price. So now N, the total number of people is 100, and the total number of people who like the price is 75. So now we get the probability to be 75 divided by 100, which is here. And then now the B part. Now the B part, I think we have moved. Yeah, now the B part, we want to find the probability of. So the B part is saying we should find the probability that the prize was won by someone who did not support the charity. So we find the probability that you supported the charity.
Yeah.
So that means we take 100 from 60 from 100, and that will give us 40. So the probability that you did not support the charity and won the ticket is 40 over 100, and that is going to give us that, because the B is saying what is the probability that the prize was won by someone who did not support the charity. That is it. And then the final one, we are looking for the intersection. So if we are looking for the intersection, that means we need the probability of the A plus the probability of the B minus their intersection. And when we do that, we'll get 35%. Now let's take another example. Let's consider a study where we are looking at the probability of being a blood group O if you are a white person. So we have 100,000 people who are white people, and those who have blood group O to be 45,000. Now, what is the probability that what is the probability of having blood group O? Now, to get that probability, the number of people who have blood group O is 45,000. And then the total number of people is 100,000. Now, the probability that you have blood group O is equals to the number of people with blood group O divided by the total number of people. So here it should be 45,000, not 44,000. So 44,000 divided by 100,000, and that is going to give us 45%. So the probability of having blood type O is 45%. The probability of having blood group O is 45% among the white population. Any question? Any question? Any question? All right, so let's move on.
No, sir.
Please, a
Now
question.
we are considering
Please, a
another
question.
example. Yes.
Please, a question.
Okay.
Please, the other example, the one with the tickets. I saw you making the intersection 100 over 100. So I don't mean, does that mean it's because all of them bought the tickets? That's why the
No,
intersection
the
is
100
100
over
over 100.
Sir, I couldn't even understand that part.
The
So please,
100
can you
over
please
100
go there and
is the universal
get the
set.
idea?
The universal set.
Yeah.
So that there is just one. So the probability of the intersection there is just one. So that's why. So it's just going to be minus one. Can you see that?
All right. Yes, sir. Thank you very much.
So let's look at the other example. So we are looking at infection here. We are looking at infection here. So we are looking at infection, and then we are saying that, so this is a particular disease that affects the intestines, and the number of positive cases is 55, and the number of negative cases is 151. Now we want to find the probability of having an infection. So we know that the probability of the number of people with positive who are positive, that is those who are tested positive, they are 59. The number of people who do not test positive, that means who have tested negative, they are 151. And that means the total number is 210. Now the probability of testing positive or having the infection is equal to the number of positive cases divided by the total number of cases. And that is going to be 59 divided by 210, and that is going to give us 28%. That is going to give us 28%. So the probability of having infection is 28%. The probability of having infection is 28%. Majority are trying to join, but their network is not good. So sometimes they can't join in. Now let's look at the second part. What is the probability that one does not have the infection? So we are looking for the opposite, the probability that one does not have the infection. Already we know the probability that one has infection to be 28%. So we just subtract this percentage from 1 so that we get the probability that one has no infection. So here, the probability that you have no infection is equal to 1 minus the probability that you have infection. So that is just going to be 1 minus 0.28, and that is going to give us 72%. The other way you can calculate it is to just say, okay, because we have the negative infections to be 151. So instead of saying 1 minus the percentage, which is 28%, we just use this number. The probability of those who are tested negative, which is 151, divided by those who have tested negative plus those who have tested positive, and that will give us 72%. So the probability of not getting the infection in this population is 72%. So there is high chance of not getting an infection if you are in this population. Any question on this question? Any question on this problem? All right, so let's move on.
No, sir.
Okay. Now, there is an example here. Okay, there is an example here. So we have 100 newborn. It should have been borns. 100 newborns in a maternity of Sunyani Municipal Hospital. So you have 100 newborns. So that means the total number of newborns, 100. And they were 55 males and 55 females and then 45 males. Then here we are saying calculate and interpret the probability that newborn baby is a female. Also calculate and interpret the probability that newborn baby is not a female. So here we find the probability of being a female and then subtract that from 1, and that will give us the probability of not being a female. Now, the probability of being a female is going to be 55 divided by the total number of newborns. So we are going to have 55 divided by 100. So the probability of that a newborn baby is going to be a female is 55 divided by 100, and that will give us 55%. Then also, if we want to get the probability that you are not a female, then we take 45 divided by 100, or we just take 1 minus 55%, and then we'll get our answer. Any question on this? So you can solve this on your own when you get time. Any question? Any question?
No, sir.
No, sir.
So now we move to the next level, which is conditional probability. So under conditional probability, we are going to estimate probabilities based on certain conditions. So under conditional probabilities, we say that conditional probabilities provide a method for updating or revising probabilities in the light of new information. So for conditional probabilities, we estimate the probability based on, so why do I always get these lines crossing my listen? So for conditional probabilities, these people are joining and they are just worrying me now. So for conditional probabilities, we estimate the probabilities based on certain information. Now, so why are these things crossing my slides? I don't know where they are coming from. Usually you just get those crosses and then this thing is going to make my work. Can you see the lines that have crossed the slides?
Yes, sir.
So I don't know how come by those lines.
Yes, sir.
I don't know how those lines happen to appear
Yes, sir.
in my slides. Come on. Let me see. I don't know why. I don't know. I'm just seeing those things. I don't know where they are coming from. But can you see what is written there?
Yes, sir.
You can see the slides again, isn't it? Can you see the slice?
Yes, we can see it again.
No,
No.
sir.
No, sir.
I'm going to share the slides again.
Thank you, sir.
Can you see the slides? Can you see the slides?
Yes, sir.
Okay. So here we are talking of
Yes,
conditional
sir. And
probability.
it's full screen too.
Okay.
Thank you, sir.
So we are talking of conditional probabilities, and we are saying that
Okay, sir.
we want to update our information.
Please,
So
sir,
this,
a question on conditional probability.
but I've not even said anything. What question do you want to ask?
Please, sir, a question on conditional probability.
I said I've not
Okay,
even
keep
said anything.
quiet.
What are you going to ask? Huh?
I
Please,
wonder.
sir, I was
The dog
I
and the
was
dog
going
is
to ask, is information or data collected from conditional probability
Come again.
reliable? I said, is the data from conditional probability reliable? Because once the data is subject to change, new results may arrive. So I don't know if it's reliable.
Okay, so conditional probability. So conditional probabilities provide information. So here we compute probabilities based on the given information. So in what we are saying simple here is that knowing that a particular event has happened, what is the probability that this event is also going to happen? So you want to do something and they tell you that, oh, this one has already happened. Then what is the probability that this event is also going to happen? For instance, the probability that you have HIV, what is the probability that you are going to die? And then the probability that you don't have, so given that you don't have HIV, what is the chance that you are going to die? So you already know that one particular event has occurred. What is the chance that the other event is also going to occur? That is what we want to look at here. So how do we write conditional probability statement? So you can see that we have written probability of B, and then there is a slash there, and then A. So what that means is the probability of B given A. So what that means is that what is the probability of event B occurring, given that event A has already occurred? This is what it means. What is the probability of event B occurring, given that event A has already occurred? So this is going to be written as probability of event A given B given event A is equal to probability of the intersection of A and then B, all that divided by probability of A. And this is the conditional probability. So if I give you the intersection of two probabilities, and I give you the individual probability A, the probability that event A has already occurred, then you should be able to find the probability of B, given that the event A has already occurred. So we said that provided that probability of A is not equal to 0. So if the probability of A is equal to 0, what that means is that the whole of probability of B given A is going to be equal to, is not going to be equal to 0. So we are saying that the probability of A should not be equal to 0. So if it is equal to 0, then our probability is going to be undefined. Okay, our probability is going to be undefined. So probability, so if the probability of A in this is equal to 0, that means the probability of B given A is going to be undefined. That is all that I'm saying. So we are saying that this probability is read as probability of B given A. Now, let's consider a situation. You know the deck of cards. Okay, some of you who play game, deck of cards, the cards. We have the king, we have the club, we have the diamond, we have the spade and all that. So in total, each of them consists of 13, 13, 13, and there are 4 of them. So that is 52 in total. So if we want to find the probability that there is a king and that king is club, so that is king of clubs, then given that there are clubs, so given that there are clubs in the deck of cards, what is the probability that the card is a club but is a king? It is the same thing as writing it as king of clubs intersection clubs divided by probability of clubs. So this is the same thing because the king of clubs is inside clubs. So we are just looking for probability of king of clubs divided by clubs. So if you are looking for king in the clubs, that means the probability of getting a king, which is a club, is just going to be 1/52. And then the probability of club, there are 13 clubs. So that means is going to be 13 divided by 52. And when you work that out, you are going to get 1/13. So in the deck of cards, if you want to find the probability that there is a king of club, given that there are clubs in the deck of cards, then that probability is going to be 1/13. Now let's take another example. Let's take another example. So suppose we have 2 events, A and B, and they are coming from a sample space. And we know that the probability of A is equal to 0.6. And the probability of B is equal to 0.2. The probability of A, given that B has already occurred, is 0.5. Now find the probability of B, given that A has occurred. B, find the probability of A union B. C, find the probability of not A, probability of A, event A not occurring, intersection B occurring. And finally, find the probability of event B, given that event A has not occurred. Here, like I always say, you use what you have to get what you want. Now, in your probability formulation, you know that probability of A, probability of event A given B is equals to probability of A intersection B over probability of B. But we know that probability of A given B, these people are just worrying me here. Probability of A given B is equal to 0.5. So we substitute 0.5, which is this one here. And then we are looking for the intersection, but we know probability of B to be 0.2. So we substitute that here. And then we solve for the intersection. So the intersection is just going to be 2 times 0.2 times 0.5. And that is going to be 0.1 as our intersection. Now let's go to question number A. Question number A is saying that find probability of A, probability of B given A. How do we express probability of A given B? This is probability of A given B. This is the same thing as probability of B intersection A divided by probability of A. But we know probability of A intersection B to be equals to 1. So we put 0.1 here. We know probability of B intersection A to be 0.1. So we put 0.1 here. Divide by probability of A. What is probability of A? Probability of A is 0.6, which is this one. And that will give us 0.17. So the probability. So the probability that event A has already occurred, given the probability of B occurring, given that event A has already occurred, is 17%. And then we go to the B. The B says find A union B. A A union B is going to be probability of A plus probability of B minus probability of A intersection B. So you just substitute the values in. A probability of A is 0.6, probability of B is 0.2, and then probability of A intersection B is 0.1. And that will give us 0.7. So the probability of A union B is equals to 70%. Now we go to the C part. The C part says probability of probability of event A not occurring, intersection probability of B occurring. And remember yesterday we talked of law of total probability. Now we have probability of B to be equals to the intersection probability plus the probability of event A not occurring, intersection B occurring. So here we are looking for this particular guy here. We are looking for this component. So that means we make this the subject from theorem 2. We make this the subject, and that is going to give a probability of B minus the intersection. And that is going to be 0.2 minus 0.1. And that gives us 0.1. Then the final one. The final one, which is D, says we should find the probability of B given that the event A has not occurred. And that is the D here. And that is going to be intersection of the B and then event A not occurring divided by probability of event A not occurring. And that is going to be, because we know the probability of B intersection not A to be equals to 0.1. So we substitute it here, 0.1. And then we know this probability. We know probability of event A occurring. So that is just going to be 1 minus probability of the event A occurring to get this guy here. And that is going to be 1 minus probability of 1 minus 0.6. And then, so this divided by that, this divided by this is going to give us 0.25. And that means the probability of B, given that the event A has already occurred, is 25%. This is where we are going to end this lecture. And then we'll continue our face-to-face next week, Monday. So if you have questions, you can ask, and then you get response from me. If you have no questions, then we end the lecture here. Any question?
Please say my question again.
Yes.
Please say my question again.
Yeah, you can ask your question.
It was on a definition of yes, please say it was on a definition of conditional probability.
Okay.
And you said the data is subject to change in the light of new information. So
sure.
I'm saying is the result just for a short time frame, or is for the long span?
So what we are saying that it is subject, or you can update your information based on the new information that you have obtained. For instance, I've stated that look at how the conditional probabilities are stated. Are they not based on new information or certain information that you know? Look at the conditional probability definition. Are they not based on information that is unknown?
Yes, sir.
So if you have your data and you have information that you already know, can't you use that as information? Can't you use your data to update that information?
All right, sir.
So sometimes, just like when you were coming to UNE, maybe someone was telling you about UNE. Okay, someone was telling you about UNE, then you get to UNE. Won't you know what UNE actually is?
Sir, please attendance.
So once you know, you know how,
Dog him.
someone is saying what? Attendance. Yeah, I think there are 53 participants.
Attendance.
52
Yes,
participants, and that is quite good. But not, I mean, not bad, because 52 is okay. Any question?
Sir, please, my name is Mintaku Bismarck. I didn't come to this class.
Come again. Someone was talking. Can you talk, please?
20 of us are using one phone. So we have to count all of us. We are 4. We are using one phone.
So I have to count all of you. You have been counted. Okay, I've counted you.
We are 5.
Okay, that's fine. Okay, so that is that. So see you on Monday. So Monday we'll write our first quiz. Monday we'll write our first quiz. Are you okay? We'll write our first quiz on Monday. Hello? 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 Hello?
You people, please, the man is recording the thing and you are moving.
Hello, sir.
So I hope you guys are fine. So we'll have our first quiz on Monday.
Sir, please, some of us are facing challenges.
Some are what?
Sorry, back. I want
Lenovo. Yeah, Lenovo, you are talking.
My mother said, if I write you
Hey, boy, bring it up.
Samira, what are you saying? Samira.
sir, please, the quiz. We want topic.
What topic on what?
The topic from which the quiz will be coming.
Oh, but I've stated that on the platform. Didn't you see that?
Okay.
I've
Sir,
stated
God
where,
bless you.
so you know where to get the quiz.
Sir, God bless you.
So we'll meet on Monday.
Yes, sir.
By Thursday, you have your handbook.
Challenges, connecting, sir. Some of us.
By Thursday, you have your handbook.
Yes, sir.
Okay, so.
Okay, sir. God bless you, sir.
Okay.
And yeah, bye-bye.
Okay,
sir.
Hello, sir.
Yes. So you are those using the double phone, right?
Okay.
The network was so bad.
Ebenezer.
Sir, please, some of us were having problems. Connecting, sir. So we didn't hear anything.
You didn't hear anything.
Buy proper phone.
Network.
It's not about the phone, bro. It's the network.
The network is not good.
Yes, sir.
Why will you use Airtel to go into that?
Amwa, your network is not good. Oh.
Hello.
Those using Glow and Airtel to go there.
The network is on.
They have to go and buy MTN because MTN money is cost and they are stingy, so they don't want to use MTN.
I'm using Vodaba. It's always connecting. So
You guys have no lectures.
No,
We
sir.
have.
we have.
There is a questions you can ask.
No, sir.
You don't have questions.
Dental. No, sir. Hello, sir.
Sir,
You don't have questions. Don't you have questions?
Charlie, Master Nivea, you know, Afrina, network in my double. To fear for before you wear your power. Oh, go.
Okay, then. Bye bye.
Mom, listen more lecture.
Hey,